Hey everyone, let's talk about solving quadratics with the quadratic formula, except a little twist to it. We are now going to have complex solutions. Kind of confusing. We've always had complex solution because every number in the world is complex. Some complex numbers though are imaginary. So let's see what this is all about. Today's focus is really on the discriminant. The discriminant is a word that describes the calculation b squared minus 4ac. So that key number, b squared minus 4ac, tells us a lot about the solutions of a quadratic equation. And you can look through your notes. For example, if the discriminant was a perfect square, well, taking the square root of a perfect square, you get a whole number and you get rational solutions. You also saw that if your number is not a perfect square, you're going to get irrational solutions. You've seen that if your discriminant value is 0, you get one distinct solution called a double root. Well, for today's work, your discriminant value, b squared minus 4ac, is going to be a negative each time. So let's get right to the practice. So what if I had the function f of x equals x squared plus 18x plus 97? I readily identify a, b, and c, 1, 18, and 97. And what I'm going to do first this time is I'm going to calculate the value of the discriminant. In other words, b squared minus 4ac, because it's kind of the biggest part of the calculation. So 18 squared minus 4 times 1 times 97 gives me a result of negative 64. You haven't had that yet. So how am I going to have the square root of a negative number? Let's see how this works. So if I were to start this problem, right, I would, and I fast forward a little bit, opposite 18 is negative 18. I have my discriminant, which is the square root of negative 64. I already calculated b squared minus 4ac. All over 2a, well, 2 times 1 is just 2. So this is a very simple way of writing it. Well, I can't take the square root of negative 64. So what I do instead is I think of the square root of negative 64 as an imaginary number. And here's how it works, all right, to take you down this little concept. The square root of 64 is essentially the same as the square root of negative 1 times the square root of 64. Now, I have no problem with the square root of 64. It's just 8, right? It's really everything revolves around the square root of negative 1. That's a problem. So square root of negative 1, that's the imaginary number I, all right? So for our purposes, the square root of negative 64 will now be known as 8i, 8i. That's really the only difference with the assignment. So if I am to reduce this fraction, I divide everything by 2, and I get negative 9 plus or minus 4i, which means my two solutions are negative 9 plus 4i and negative 9 minus 4i. Confusing? Maybe a little bit. Let's take a look at another example. All right, so I'm going to turn this off, and let's cut out this annotation. All right, so what if we looked at a more advanced example? Okay, so here we go. We've got 9x squared minus 48x plus 68. Again, I'm asked to find the complex roots. In case you haven't noticed, finding the complex roots means solving the quadratic equation, setting it equal to 0, using your a as 9, your b as negative 48, and your c as 68. So once again, I'm going to go straight to the discriminant. I'm going to say negative 48 quantity squared minus 4 times 9 times 68 gives me a grand total of negative 144. So opposite b is 48 plus or minus the square root of the discriminant, which is negative 144, all divided by 2a, which is 2 times 9, or 18. All right, so now that I'm more fluent with the quadratic formula, it's okay to skip a couple of steps, all right, but that's completely up to you. So let's get to work. Again, the whole problem is with this being negative, so I'm going to break this up into the square root of negative 1 times the square root of 144. Once again, I have no problem with the square root of 144. That's just 12. The square root of negative 1, that's just I. So I'm left with 48 plus or minus 12i divided by 18. All of these terms are divisible by 6, so I reduce it to 8 plus or minus 2i over 3. All right, conclusion is you treat this just like you did problems yesterday. The only difference is when you have the square root of a negative, isolate the square root of negative 1, simplify it to I. Now, you might have some examples where the square root is not a perfect square. Remember, if the square root is not a perfect square, such as, let's say, square root of 120, break it up into a product with a large perfect square, just like yesterday. That's the lesson.